Hi, this is your lesson on energy resources in the hydrosphere. So we'll let you get started right away. Want to let you all have a guess. Hopefully it's not a guess. When was the James Bay and Northern Quebec Agreement, the JBNQA, signed? You all get a holiday every November 11th for the day this was signed. I'm asking you to tell me the year. You can go ahead and pause if you want to have a discussion. This is something you would have seen in history class as well. So go ahead and pause, have your discussion. All right, so when was the JBNQA signed? It was signed in 1975. All right. And actually that kind of relates a lot to our lesson today, so we'll keep going. Here's what we are talking about. We'll be asking ourselves, what is hydraulic energy? How is hydraulic energy harnessed? So how do we manage to extract it, get it, use it? How does hydraulic energy impact the environment? So your essential question are done. Your lesson objective, what you need to be able to do, I can judge the impacts of energy extraction and use, which means that you need to be able to tell us the advantages and disadvantages of hydraulic energy at the end of the lesson. What is it good for? What's good about it? And what's not so great about it? All right, let's go. So hydraulic energy is energy that can be made from moving water. Moving water is a tremendous source of energy. So we get a lot of energy from moving water. Transforming this energy into electricity is a massive challenge because of the enormous facilities that are required. So you need really big dams and hydro plants to make this possible. All right. So Quebec generates almost all of its electricity in hydroelectric power plants. So first a dam is built across a river which holds back its waters, and this creates a huge artificial lake. So you've seen this actually in Cree territory. There's a lot of damming that's been going on, so I think we definitely know one of the disadvantages already of this. So first we build a big dam, holds back the water, doesn't let water flow the way it used to, disrupts a watershed, creates a huge artificial lake. Then a buildup of water, so here's where the water is being built up. This creates a lot of pressure. So to make electricity, we open the dam gates, water goes through, rushing through, and we get to these turbines, and the water spins around in here, turning the turbines. And the turbines are connected to alternators that convert that mechanical energy into electric current. And so then we have all this turning down here being converted into electricity and sent out through those good old transmission lines. So hydroelectric power depends on a renewable resource, water. So the idea is that water is not going anywhere. We'll always have these rivers flowing and flowing again and again and again. So this is kind of nice. And it does not produce a lot of greenhouse gas. So these are two advantages. It's renewable and it doesn't produce a lot of greenhouse gas. So we don't have to worry as much about climate change this way. How does electric power affect the environment though? So hydroelectric power requires flooding hundreds of square kilometers. So the EU people know this really well, right? Because that's unfortunately what has happened in a lot of the James Bay area. Hundreds and hundreds of square kilometers flooding. So this swallows entire ecosystems. Lots of people lost their trap lines and all of this, their ancestral territories because of hydro dams. And so we displace people. And we also displace all these animals when we do that. The other thing that can happen is mercury. So mercury from industrial activities that built up in the soil before the flooding. Once the flooding happens, the soil is covered in water, and that mercury is then converted by bacteria into something called methylmercury. And this is it's a toxic compound stored in the bodies of fish, and then when people eat the fish or other animals who eat the fish, it also gets into people. And methylmercury is actually pretty dangerous if you consume it in high amounts. I included this just for your interest. It shows you areas where people fish, and kind of basically you have the they're showing you where people are fishing from, and to be wary of some of these fish. So depending on where you're fishing, they're saying that you shouldn't have as much of these fish. So for example, if you are fishing over here in the area they call the Rupert Division Bays and the upper Nemasco River, if you fish around the dams there and you catch lake trout or pike, you should really only be eating that once a month because it has a lot of methylmercury in it. If you want to pause the video and get a good look at this map, you're more than welcome to do that. But for the sake of time and the amount of time it takes to upload these videos, I'm going to keep going. So go ahead and pause if you like, but I'm moving on. Alright, so mercury from industrial activities, it's there and it's getting stored in the bodies of fish. So here's some possible symptoms of methylmercury poisoning. So people can lose their peripheral vision. That's the vision you have from the side of your head. You do need your peripheral vision. People also get pins and needles feelings, so usually that happens in their hands and feet and around their mouth. You can have a lack of coordination of movements, so people can start to look as though maybe they are drunk, even though they're not. An impairment of speech, so it can make talking more difficult, hearing more difficult, walking more difficult. It can also give you muscle weakness. All of this, of course, is dependent on how often you are exposed. So the idea is to avoid fishing in areas where there would be high concentrations of methylmercury, and if you do, then to not eat those fish as frequently. Alright, another kind of energy resource that we are working on. This is actually a computer generated photo. We haven't done this yet. It's still in the prototype stage. But we're talking about waves and ocean currents. So waves and ocean currents also have a lot of energy in them. And so engineers are trying to develop systems to transform them into electrical power. So we wouldn't dam, we would just stick big turbines, almost like underwater windmills, to the bottom of the ocean and see what happens. This is really expensive and still, like I said, in the prototype stage, so we haven't done this yet. But it might be some energy of the future. So here's what you need to be able to do now that we've reached the end of the lesson. You need to be able to define hydraulic energy. What is it? How do we get it? That sort of thing. How do we turn hydraulic energy into electricity? You'll be able to explain that. And describe how hydraulic energy affects the environment. So what is good about it and what is bad about what it does to the environment. And that is the end of today. So actually after today's lesson you should have time to work on a Hydrosphere assignment in your workbooks. And that should prepare you for your quiz. Remember that you can always revisit some of these lessons too. They're all on YouTube if you want to study for your quiz as well. Good luck.